circuitry of a common emitter circuit amplifier using NPN transistor. Let me just share my screen. Okay. Okay. So this was a circuit that we were doing, and this is a common emitter circuit, which is actually the most popular circuit in amplifier. Even later on, we'll be looking at classes of various power amplifier, and the first class that we will look at class A is actually pretty similar or to this one. So yes, it is one of the most prominent or circuit that has been used in most of the transistor applications. But there are other configurations also, like common collector, common base. We will look at those also, and what are the differences and benefits of all these classes and everything. Will obviously you are already aware about all that, so I'll not go into that part of these configurations. Okay, so as I said, let me just quickly revise this one. Like if I do this AC sweep, you can see that around 500 hertz, uh, this output will cross my input. This is green one, and it will increase, and start decreasing around 2.5k. Then by 10k, it will start decreasing. 10 with 10 will deteriorate. It will go below my original signal. So amplification will happen from 500 hertz to 10 kilohertz. And other than that, for all the frequency, the signal will be suppressed. Okay? So let us just check that also. So let me give it some frequency, which is let's say 7.7 hertz. So my signal is coming. You can see both the blue and the green signal. Yes, so some counter division and signal. So you see there is a signal. There is a very small signal. You can see it, it's almost zero. So we know that after 500, the signal will start increasing. Once I start increasing this, and after 500 hertz, it will surpass the original signal. That means it will be amplified. That this increases signal. So you see the signal is increasing a bit, but obviously it is less than my original signal. See, this is increasing. Oh, sorry, I increased the voltage. So if I start increasing, you can see that my blue signal is increasing. So time to division. Okay, and after 500, it will cross my original signal. Okay, and again, you can see the output is increasing. We are roughly at 500 now. You see, at 500 hertz, both the signals are almost same. Okay, which anyway we also anticipated from our frequency response circuit. Both are almost same. Now, if I start increasing my signal, will surpass the input signal. So if I keep on increasing, and I know after 10 kilohertz, it will start coming down. You can see that it is increasing, increasing, but as soon as we came around 9 kilohertz, it has started decreasing. Okay, so now we are at 10K. You can see that signal has started going down. So the band for this particular amplifier is 500 hertz to 10K hertz, or maybe to be more precise, somewhere around 9 kilohertz. Okay, any doubt on this?
No, sir.
Okay, so this was about our common emitter. There are no doubts. The next one that we have to do is the common base. Common base, I guess. So next one is common base. Common base circuit will look like this. Okay, and again, obviously, I will not be calculating all this resistance capacitance value correctly. So our result might not be that efficient. Okay. So let me just make the circuit quickly. What else we need? Uh, 5 resistance and 3 capacitors. Five resistance and 3 capacitors. So this is what I need. I will be one input source and obviously ground and my DC biasing also. Okay, now just look at the circuit. Here are my bases are connected over there. Okay, let me just quickly connect all of these. One from there. Next one is this one of input is connected there to this capacitor. All of this will be ground. Strip ones. Okay. Yes. Okay, so we have given the right circuit. Let's just do this install mode. And then our input, let's say 100 milli. You can see like the nodes. Now give me one probe for input. The probe here for this. Run the system. See on the graph what we are getting. Obviously, output is 0 right now. just try to make some changes here.
Sir, base is not grounded. Sir,
Ground is also not connected now.
sir,
Hello.
C1 should be connected with ground, sir. Base capacitor,
Okay.
sir,
Ground.
that is not grounded.
Ground is also not
Got it. Got it.
sir.
Yeah. Ground signal is not connected. Should be here.
So capacitor should be also
Okay, so
grounded,
where
upper
are these?
capacitor.
Capacitor
Which
C1.
capacitor? No, this one.
C1, sir.
C1, sir.
C1 is grounded, na? You see,
Okay.
this line is ground line. So
Okay.
all this resistance and this capacitor are grounded.
Okay, sir.
Okay, so you can see now we have a signal which is very small, obviously. So because our gain is not good enough right now, so let us just try to make some changes. You see this signal. Okay, so we should give something here. Okay, so let us just try to change these values and see if we can amplify our output AC. We are getting some amplification here. Okay, let us just try to see what can we will do. Okay, not so much effect. Okay, so not zero. Okay, so this one, what it will do. Okay, so now this one is increasing our output. Okay, so now the output is over my input, as you can see clearly. Okay, so now if I stop and do the AC analysis, let us just see what it will be. So you can see now output will surpass my original input. We will test it. Okay, then after 7 hertz, this is almost constant, or 6 hertz, it is almost constant. Okay, you can see the saturation point. So from okay, so 3 hertz, it should be less than my what you would say output input, sorry. Okay, you can see here the frequency is 10 millihertz here right now. So let me just try to increase, and we'll see at around 3 hertz it will surpass my input. So we are at 1 hertz and it has increased significantly. Okay, so let me increase it some more. You can see that. Okay, so it has surpassed now. So now you see we are roughly at 3.15 hertz, and it is almost same as my circuit, my input. So now it will surpass it. Okay, and it was going till what, I guess 10K. Let me just okay, so let us just go a bit more. Okay, so 1K. Okay, okay, so now let us just increase it a little more. So we are at 10K now. So let me increase a little bit. Let me increase this more. So it is saturated after it. Oh, sorry, yeah. That is what we were checking. That after 10 it will be saturated. So the output will be constant always. And around 3 hertz it will surpass it. And after 10 it will be saturated. So below 10, it was increasing. Okay, so this is what we were trying to achieve in our common base amplifier. Okay, so this we have achieved. So if I, let's say, let us just see what all effect does these component have. Like this, I made 100 microfarad, and this was my response. So at 3 it was surpassing my input. So let me just decrease it to, let's say, 10 and see what happens. So now it is going around 30. So exactly a tenfold has happened. Okay, so earlier it was surpassing around 3, now it is surpassing around 30. So that is the change, and we decreased it by a factor of 10. So we can easily see that this is not inversely proportional to my gain, this particular capacitor. Okay, and what all we can try to change. Okay, let's say try to change some resistance. Okay, so from 1k, let me make it 10k and run it. You see the gain has decreased. Earlier it was going up till this point, and now it is coming at this point. Okay, and it is saturating around 1k itself. Okay, so all these things you can see. Okay, what parameters now? Anyway, I don't remember the formula, so I'm just using hit and trial here, which you can see that what effects are having these things are having here. Okay, so this was our common base amplifier. Any doubts on this?
Sir, can we change
Anyone
the
having any doubt on
y-axis?
this?
Sir, y-axis scale from logarithmic to decibel. Can we change that scale, sir?
This one.
Y-axis, sir.
Let me just
Logarithmic scale to decibel. Can we convert that, sir?
let me just check now. I'm also not okay. I guess there is linear or decibel. Decibel we have changed it,
Yes.
and we
Right.
can change it to linear also. We can change it to octave also.
Yes.
So these optionalities are there.
Yes.
Like
Thank
this
you,
is
sir.
decibel. Any further questions? Even see we can put in these cursors also, which can help us obtain the exact values. Like if I put it here, you can see that this is giving me the value, x and y values. And this is my y, and this also is giving the value. You can see here. Okay, and if I want it on x, that also I can do. You can check here. Okay, so there are various options that one can uh, check here. Obviously, I'm not checking all of them. So the documentation part is also there, like C frequency. I think someone was asking us, so we can change it here. So let's say if I want it till 10k only. So let me just run it now once. You see now I have till 10k only, so I can change that also. So under documentation, I can change my start frequency as 0. Start frequency must be a number greater than 0. Okay, so let me make it 0.1. Okay, 0.01. So let me run it now. So you can see 10 from 10 milli I started, and you can see I went up till 10k. So all these optionalities are here. Then this also you can check. Okay, so like the change I made here is linear, not decade. Okay, so logarithmic scale, linear scale, decibel scale also we can change. Logic level, this sheet width and all, if I want grid or not. Let's see if I don't. So what would be like this? Okay, so all these things can be done, and these will help us in analysis of our result. Okay, so this is something that you can always look into. Any doubts on this? Any doubts?
No, sir.
Okay, so we will move toward our next circuit, which will be 1 second, which would be our common collector circuit. Okay, just give me a second. Okay, so yeah, sorry. So we'll move now. Let me just save this one as common uh, base amplifier, and this one is NPN. So something similar can be done with PNP also. So okay, so this one is saved, and if I go into my circuits now, I should be able to see this one here, common base. Okay, so now our next circuit is going to be common collector circuit. Okay, so common collector circuit would look something like this. Okay, so there we have again our NPN transistor, and obviously some this. Okay, so the one difference that I can notice is that in common emitter we were taking output from here, but in this case we are taking from here through this capacitor. Okay, so this is one difference from common emitter. So let us just try to make this one. Okay, so one transistor. Okay, then what all we need? Okay, one, two, three, four resistance and two capacitors. Four resistance and two capacitors. One would come here, another would come here. And what I can see, I guess we will need one more resistance here. Okay, so let me just quickly. Okay, then obviously we will need one input supply and DC biasing supply here at the top. Then some grounds we will need. Okay, so one ground would be here. Yes, here.
Hello, hello,
Hello, ma'am.
I think there is some technical problem. I think
hello.
it might
I
take.
think Devender sir, actually, I don't have his contact number. I'll just call him and ask. He's disconnected from the session right now.
Okay, ma'am.
Kindly wait, participants. I'm just connecting with sir.
Yes, ma'am. Sure.
I think someone can try to contact him. I think someone can try to contact him. Definitely, they will make some arrangement.
Sir, Neha ma'am must be contacting.
Ah, yes.
Yes.
Yes, ma'am. We are just contacting him. Might be internet issue at his end. So
Yes.
another 2-3 minutes.
Okay.
Hello. Neha, am I
Yes,
audible?
sir. Yes, sir. Yes, sir.
Yeah, I
Yes,
didn't
sir,
realize
audible.
my signal got cut down in between. So till what point I was there?
Sir,
Can
you were
anyone?
discussing common collector circuit, sir. You
So
were doing connections, sir.
1 second, let me just share my screen. Okay, so this we have discussed.
Yes, sir. This was done,
Okay,
sir.
okay, so this was done, and basically we are lacking some configuration and exact values here. That is why our signal is not amplifying. We are getting exact same signal output as our input. You can see here on the chart. Okay, and yes, so this we can save it. N npn common. uh, amplifier. So this I will save in my circuits. Okay, so that we can later on try to change the value and get the proper output. Okay, so this is another circuit. So we have done 3 configurations: common collector, common emitter, common base. So these 3 are actually our, we can say, the base element of any amplifier circuit. And most of the time we will be using common emitter only, not common collector or common base. They are used rarely, but most of the time is common emitter circuit that we will be using. Okay, so okay, so I have multiple circuit, and I'll delete it later on. So this was one thing. Now we will look at some classes of our amplifier. Now power amplifiers, basically power amplifier is what we'll look into now. So power amplifiers, they're used to increase the power magnitude of power, which is our multiplication product of our voltage and current on the output side only. Okay, so most of the time these power amplifier you can see in applications like speaker and all. Whenever you're dealing with audio signals or any radio signals, where you want to where you're receiving a very low voltage signal. Let's say if I'm using a mic right now to speak, and this would be generating a signal which is in millivolt. Okay, so we need to amplify the power of the signal so that it can go further, or if we are playing it on a speaker, so that it can have a better sound quality on the output end. So that is why we use these amplifier in between. Now there are multiple classes of these power amplifier, which will actually be derived on our circuits that we have done up till now. So if you see class A amplifier, this is pretty common again, and this is actually somewhat similar to our common emitter circuit only. You can check this; it is very similar to that one. Okay, so instead of a load, we have a speaker here. You can see then 2 resistance. Only thing, we had 1 resistance there also and 1 resistance here also. So this particular thing is your assignment for today, class A amplifier. Okay, so you have to make this class A amplifier, and we can discuss it tomorrow if there are any doubts into this. Okay, but yes, this is your assignment for today. So class A amplifier.
Sir, for
Just take a
speaker,
no,
sir,
instead of speaker you can put, obviously you can
prop.
put a resistance also.
Okay,
Plus
sir.
one
Can I
more
put
thing,
LED?
we actually have buzzer also here. Let me just show you where is it. Oh, we have a
So
buzzer
can
here
we
also.
place LED?
What's up?
LED, can we put LED?
You can put a normal resistance. You don't have to put a speaker also only, but you have a buzzer in here which you can use if you want. Okay, so under this indicators here, you see you have a buzzer. Okay, so this buzzer you can use if you want,
Oh,
or
okay.
otherwise simplest thing would be to use a resistance again as a load resistance. So that particular thing there is just to just acting as a load. Okay, we can give anything as a load. Okay, so in case of power amplifier, obviously putting an LED might be not a good idea, because it would be having a lot of power, and LEDs are low voltage devices. So you can put in a lamp or a buzzer, or simply a resistance would do the job. Okay, so just take a screenshot, or anyway this thing is available on Google also if you want, uh, so that you can just check. Okay, so have you taken the screenshot?
Yes, sir, done.
Okay, so this is again assignment for today. Now the next thing that we can classes, class B, then we have class KB, and we have class C also. Okay, so I'm not sure if we'll be able to cover all this, but yes, class B I would like to cover. Okay, so this is the circuit, basic circuitry, and again I will not be going into the exact values. So let me just quickly design this. So we have one NPN and one PNP transistor, two resistance here, two capacitance, two resistance here, and that's it. Simple enough. So let us just quickly make this one. We have NPN here. We have PNP here. Okay. Then we need four resistors. Okay. 1 second. Like this, we have four resistors. Okay. Then we have just two capacitors. Yeah, two capacitors. Okay, so somewhat like this, and obviously we will need one more resistance as in our load. Okay, so this is our circuit. Just place it properly. Okay, so here we are. Here. Okay, we will need now our input signal, and obviously a ground also we will need. Then we will need our biasing voltage. Let me just put it like this now. Okay, then one more ground we will need for this. So here. Okay, now just look at the circuit. Okay, so here. Okay, so this is connected, and this will connect to this. Then what is we having? Okay, so this is coming here. This is coming here, and then what we have. Okay, so this is connected to this, and this one will be connected here. Okay, so both are connected. Then our input is connected here. So this is our ground line. Okay, and this will be connected to our load resistance here. So and the other end is coming here. So let us just check if it is okay. There is one load resistance from here. Oh, I connected it. This has to be here. Okay. Now we will need two ports, one for input, another for output here. Okay, so let us just try to run this now. Okay. Okay. So we have the amplified input, but amplitude looks to be almost same. Okay, so let us just try to change the values and see what effect does they have. Okay, so this capacitance, not much effect. Okay, this also won't have much effect. So change this here.
Excuse me,
It's
sir.
almost, yes, ma'am.
Sir, you have used one NPN transistor and one PNP.
Yes, ma'am.
They should be identical or complementary, sir. Means both
Uh,
NPN or one NPN and one PNP.
Complementary, ma'am.
Complementary. Okay, sir.
Like you see in class B, we
Yes.
use one NPN and PNP, so
Okay, sir.
complementary. Like you
Yes.
can see here now, working wise, if you see, so this will give you the positive edge,
Yes.
positive cycle, and from here you will get the negative cycle, which is making a complete cycle around this RL.
Okay, sir.
Okay, so
Right.
they are working complementary here.
Yes.
Okay, so let us just try to see what more can be changed. Maybe we need to put some capacitance here to and see now what is the result. Okay, so now we have the DC that we were getting is not into picture now, and we have exactly same output as our input. This capacitance is not doing much effect afterwards. Okay, so let me just run AC sweep of this to find out at what frequency this will work. Okay, so again you can see that it is going to be just equal to our signal. It will not surpass it, so it will not get amplified. And the reason being our configuration, obviously. Okay, so let us just try to change few things and see if anything changes. Okay, not so much. Okay, and So let us just try and add some more components here. Still nothing. That is okay. Okay. So anyway, this is a configuration. We are missing something again here also. So this is what our class B would look like. Okay, so we can save it for later on, and we can check for the exact values that we need in order to get this correct output, amplified output on our streets. So that we can look later on. Okay, any doubts on this? Are there any doubts?
No, sir.
No, sir.
Yeah, okay. So let us just search class AB amplifier. We see if someone already has done some exact. No, this is class C. Again, class C. So we were doing what class B we are doing. Sorry, class B we are doing, not AB. Let us look at this one. It's a dev use diode. I guess this one should be class B. Maybe, not sure. So our output is again there are some error in this particular circuit, so this won't work. So anyway, let us just close this one. Okay, so anyway, we are just missing some values here, so that will look later on. Let us just save it. Class B amplifier and save it. Okay. So now class AB is there, which exactly is like that only, but we have these diodes here instead of resistances, and we have a capacitor here. So we will be using again same NP and PNP. Then the last one is class C, which is like this. We have inductor and a capacitance here at the collector end, and a simple bias resistors on base. So two simple classes. Let's just try this one. This class A. We'll leave class C. So we'll try to implement it in few minutes. So PN transistor, PNP transistor, diodes, capacitors. Okay. Resistance, capacitor B, resistance. That's it. Input voltage, pricing, just to plan for the thing, and our resistance also. So now let's connect this sequence. So parallel is this connected. Resistance, ECE, resistance. Yeah, this one is going this. So one capacitor, diodes, then we will have another capacitor here. So this will down, this, this, this here, this will be this,
Sir, voice is not clear, sir.
one by four, so just run this, let's see, oops.
Sir, your voice is breaking, sir.
So we have some signal here which is very low frequency signal. So let's try to increase some values and see something. Oops. About this resistance. Increased. So this is because some offset come and the offset is that is so back to the but they're also looking the same. So it is coming down. Stop. Just making our configuration. You see both are parallel lines. Green and red. So they will be same on all the frequency. Doesn't matter what frequency I use. That is that also. Is it? So both are exactly there. You can change my frequency. Not matter. So for all the frequency, the gain remains same. So the class AB. Any questions on this? Are there any questions?
No, sir.
If there are no questions, maybe we can stop for today. So today we did some common amplifier circuit. Then we saw some classes. Okay, so this is what we generally do in our advanced electronics lab. And yes, so you can derive your lab syllabus based on this learning here. Obviously, there are multiple things, other things also like MOSFETs are also there, and you can try the MOSFET circuits also similarly. Okay, so if no questions are there, maybe we can stop for today.
Yes, sir. We can wind up, sir.
Yes, I guess Neha ma'am.
Yes, sir, we can close, sir.
Sure, ma'am.
And I would like to thank you on behalf of Dr. Balwinder because he's not connected, he's in some urgent meeting. And we'll be connecting again with this tomorrow at 10 with the same link. Thank you, sir, for the session.
Thank you, ma'am.
Thank
Thank
you.
you, sir.
Thank you,
And
ma'am.
also, you can check the chat
Thank you,
box.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you,
Thank
everyone.
Thank you,
We'll
sir.
see you. We'll meet tomorrow, and tomorrow we'll be going to the